assigning oxidation numbers.
Video 3.
Yeah, redox unit, video 3. We are going to follow the rules for assigning oxidation numbers, and there's really 2. It's really easy.
Yeah.
Oil
rig. Oxidation is losing electrons. Reduction is gaining electrons. Notice I threw that electron in there.
Yep. So that's the basic mnemonic for remembering what oxidation and reduction are. Now, remember, we've been saying this over and over. If there's a reduction, there also must be an oxidation. Simple enough.
You got to find them both.
One atom loses an electron, the other one's going to pick it up. That's all there is to it. And vice versa. Absolutely. If there's an oxidation, there must be a reduction.
But they're happening simultaneously. It's not one then the other. It's a constant thing.
Mutual and simultaneous.
Yes. Very good.
So it's simple. Oxidation numbers are actually mad easy.
Yeah.
You just have to invoke a little bit of algebra sometimes and a couple rules. Simply put, any element that's by itself in its pure form has an oxidation state of 0. Why don't you throw one of the Hofbrinkel, the diatomic 7 up there too?
Oh, okay. Like H2.
2.
Oh.
That has an oxidation state of 0. Cl2, oxidation state of 0. So any pure element, whether it's a diatomic element or monatomic element, has an oxidation state of 0. That's confusing because you'll look up your elements on the periodic table and none of them in the oxidation number spot in the corner in the tile have zeros.
No, so basic rule.
Basic rule. That's the fact you got to remember.
If it's alone, it's 0.
Absolutely.
And then after that, we got to figure them out. But remember, ions are not. So if you do see an ion, like an Fe plus 3, its oxidation state is plus 3. It's giving it to you.
Yes.
So there's another one. That one's kind of almost so easy we don't need to talk about it.
Compounds are mad easy because you just uncrisscross the subscripts to determine the charges, or I call it the charge cancellation technique.
Right.
And so for calcium chloride, what you basically do is you pick out your periodic table and you start looking up the elements in the optional oxidation states that are presented. And if you find calcium,
crisscross actually.
Calcium, it says it's a plus 2. Okay, that's great. And chlorine has like 4 options. But if calcium's a plus 2 and there's 2 negative 1s, chlorine has to be a negative 1 each as well. So we're really just doing charge cancellation to find out what the oxidation state would be. And it's really easy for binary ionic compounds containing 2 elements. It's a little more complex when you get
that middle element. Yeah, that middle element. What's nice about this particular example is calcium only has the one choice.
Yes.
And believe it or not, chlorine, because we always go positive and then negative, only has the one negative choice. So that one is pretty straightforward.
Can I do the next one?
Oh, absolutely.
Cool.
Fun. All right, so now we got 3. We got KMnO4. So I'm going to look at my periodic table. There's some things that Monaco and I have really come to know. First rule is this. Ready? Oxygen is always a -2. Very rarely you're going to find it not be a -2. And then when I look up potassium, it only has a +1 charge. So my total plus charges right now is 1, plus some number for Mn is going to equal this total -8. Does that sound about right?
We got to get everything to add up to 0.
Right. Oh, that's what I mean. Yeah. So 1 plus 7 would be 8, and then give me a minus.
What are you talking about? You're messing me up.
Yeah, I am messing you up.
I think we should
I just solve algebra.
Get over on that.
Oh man, hurry up because this is a long video. No, I'm just kidding. We'll start over. You talk. No. K is a +1. Mn we don't really know because if we look, Mn's got a bunch of particular choices. I'm telling you, O is always -2, just about all the time. So I have a total -8 charge. With the K, I only have a total +1 charge. So I need Mn to be a plus value that cancels out that -8. Is that better?
Yes.
So add it all up, do your algebra, and I got -7 plus x equals 0. So -7 plus 7, x equals 7. Now when I check, wait, look, Mn, there it is, ready? Can you see Mn? It has a choice of 7. Pick it.
One of the options.
Pick it.
So obviously the way Monaco does it's a little bit more involved, but it shows you every ion and every charge, so the algebra actually works.
Yeah.
Milks's method is a great shortcut, but you're going to run into trouble necessarily if you have 3 elements involved. it's easy for his method if you're uncrisscross things, but that's only with 2 elements.
Right.
You got 3 elements involved. You
It's
gotta go to
Yep.
the charge cancellation.
Yeah, let's try another one.
You want to do your method or my method?
Well, I don't really do the cancellation method, but I just kind of total them up at the bottom. For me, it makes it a little faster.
Okay. So he's going to whip out the atoms here. So you got the
K.
K. K's only option is +1.
Right, and I got 2, right?
And
I got
2
a minus
oxygens.
2 and a +1. So when I say +1 times 1, I get a +1,
Mm-hmm.
and -2 times a +2, I get a -4.
Right.
And now I'm just looking for a number that gets me from this whole thing to be 0.
Right.
So in my brain, I say +1 plus what equals 4. Because I know I need my whole plus to be 4. When I do it that way, I say, oh, +3.
Okay. So
Is chlorine got a +3 chart?
chlorine has, an option of +3. It must by necessity. The chart doesn't show it, but that's why we have to teach you this method because some of the oxidation states for chlorine don't actually show up on the periodic table there.
This is a cool one because this is, of course, the same.
Mm-hmm. So it's the same scenario where oxygen is always going to be -2.
Okay.
Okay. And potassium is always going to be +1.
So total charge here is a +1.
And then total charge there is a -8. And he's got to figure out what number to add to the +1 to get a +8 so that the -8 cancels, and he's going to pick +7, which, if you look on the periodic table, that is one of the options. Okay.
Sweet.
So good luck there. But the first one with KClO2, it wasn't there. So you
Right.
have to know the charge cancellation technique for it to work out.
And these
You saw
were
it
great,
Mills'
these were
way.
great examples to show you that same atom chlorine, different charges.
Absolutely. So that's what it comes down to when we're doing oxidation numbers of elements within compounds.
Right. Oh, guess what?
That's all, folks.
Awesome. Practice.
See it.